So today we're going to continue on with these exponential properties, all right, properties of exponents. Yesterday we worked on the stuff with products, okay, multiplying with exponents. Today we're going to be working with quotients. Remember, quotients are talking about when we're dividing. So when we're dividing with exponents, you have a different set of laws of exponents that you have to follow, or properties of exponents. So they're very similar, just with minor differences. Okay, so this first one here is called the quotient of powers property. Okay, we had the product of powers property. Remember, when you multiplied two things with the same base, you added the exponents. Well, the quotient of powers property is very similar, but when you're dividing, okay, you notice here that we've got the same base. They're both a. The exponents are m and n. When you're dividing between the two instead of multiplying, instead of adding up your exponents, you're going to subtract the exponents. Okay, so a to the m power divided by a to the n power is going to be a to the m minus n power. All right, so this example down here, we've got 4 to the 7th divided by 4 squared. So they do have the same base. Remember, you keep the same base. You keep the 4. All right, you don't have to divide 4 by 4. Okay, you keep the 4 there. It's the same base. But what we're doing is we're going to divide these two numbers together. So because you're dividing, you subtract the two exponents. So it's going to be 4 to the 7th minus 4 squared, okay, which is going to be 4 to the 5th power. Okay, another way to think about this, just to show you another option of maybe this will help clear things up for you. You know that 4 to the 7th is the same as 4 times 4 times 4 times 4 times 4 times 4 times 4, right? And we're dividing by 4 squared, which is just 4 times 4. Okay, so if you're dividing all these, right, you'd cancel out those 4s, and you'd cancel out those 4s, and how many 4s you left? 1, 2, 3, 4, 5. That's how we get 4 to the 5th power. Okay, that's might be helpful to you. If that was confusing, just stick with the quotient of powers property. You just subtract the exponents. Okay, now the power of a quotient. Remember, if we were multiplying two things inside of our parentheses and just doing one power on them, remember, you distribute it to both of them. Okay, same way for a quotient. If you're dividing two things, and while you're dividing those two things, you've got to raise that fraction, or that quotient, to an exponent. You enact that power, or distribute that power, to both the a and the b. So that means you'll have a to the m over b to the m. Example here, we've got 3 over 2 to the 7th power. So we're going to take this 7, the 7th power, and we're going to enact that power on both the 3 and the 2. So we'll have 3 to the 7th over 2 to the 7th, which you could actually get an answer for, but you don't need to in a problem like this. Okay? So we'll jump right in the examples here. We've got, to simplify all of these, okay, we've got 9 to the 12th over 9 to the 5th. Now remember, the quotient of powers, okay, we've got the same base there. Both of them are 9, so you keep that base, and you take the top number and subtract the bottom number from it for the exponent. So 12 minus 5. So you've got 9 to the 12 minus 5 power. Simplify up there, and we've got 9 to the 7th power. All right. We deal with negatives the same way that we did in the past with the products. So we've got negative 2 as our base. Because negative 2 is our base, we're going to keep it. All right. Make sure you put a parentheses around it so I know that you are enacting the power over the entire negative 2, not just the 2. Okay, we've got this to the 4 minus 3 power. Okay, so it's going to be negative 2 to the first power, and we all know negative 2 to the first power is just negative 2, so that would be the correct answer. Okay, now we'll start stacking some stuff on top of it, right? Start to combine and make a little bit more difficult problems. So we've got 6 to the 3rd times 6 to the 4th all over 6 squared. Okay, so if you have something like this, before you divide, you have to combine your top. Okay, we need to combine those first. So we already know how to do that because we've done the product of powers last section, I'm sorry. So we've got 6 to the 3rd times 6 to the 4th is 6 to the 3 plus 4 power. All right, and your 6 squared is not changing. We'll combine those up top, and we've got 6 to the 7th power over 6 squared. Now we can do quotient of powers. So we'll subtract, keep our same base, 7 minus 2 power, which is 6 to the 5th power. Not overly difficult, kind of simple stuff, but make sure you don't skip any steps. Okay, number 4 here. Number 4, we've got 1 over r squared times r to the 8th. Okay, this is going to bring in some multiplying fraction stuff. So we know that to multiply fractions, we just multiply straight across. So 1 over r squared times r to the 8th. Well, r to the 8th is the same thing as r to the 8th over 1. You need to have a fraction for both in order to do the multiplication. And then we multiply straight across, the top and the bottom. So 1 times r to the 8th is r to the 8th. R squared times 1 is r squared. And we've got r to the 8th divided by r squared. So now we can use our quotients of powers rule. So we keep our same base, keep our r there. Remember that you have to have the same base. You have to both have the base both be r, or both be 6, or both be -2, or whatever it is. They have to be the same base in order to use your quotient of powers rule. Okay, so because they are the same base, you keep it as r to the 8 minus 2 power, which is r to the 6th. Just like that. 4 more examples for you. We're halfway there. Okay, we're going to bring in the power of quotients rule. Okay, so remember for this one, if you have just a fraction or a quotient on the inside, and you enact an exponent on that, you're going to distribute it to both the top and the bottom. Okay, so for this first one, very simply, we've got c to the 6th, right? We're going to distribute that 6 to both of them, c to the 6th over d to the 6th. Okay, you just leave it just like that. Okay, remember it's d to the 6th, not 6 times d. Make sure you keep that clear. All right, the second problem here. We're going to distribute that 4 to the top and bottom. So we'll have on top -2. Remember to keep that in parentheses so we know it's the whole -2 that the 4th power is acting on, not just the 2. To the 4th power over y to the 4th power. Okay, -2 to the 4th is -2 times -2 times -2 times -2. Okay, we know that -2 times -2 is 4, positive 4. -2 times -2 is positive 4. 4 times 4 is 16. Okay, so -2 to the 4th is 16. And then the denominator we keep y to the 4th. Looks just like that. All right. Number 7 here. All right, same concept. We're going to take this cubed and we're going to distribute it to both top and the bottom. Remember to put parentheses around it so we know that we're working the cubed around the whole entire 3a to the 4th and the whole 5b. So it's going to be parentheses 3a to the 4th to the 3rd all over 5b to the 3rd. Okay, so now we need to do our power to a power rule, okay, from last section. So then we take this 3, we need to remember to distribute it, right, to both the 3 and the a to the 4th. And distribute this 3 to both the 5 and the b. Alright, when we work that out, we're going to get 3 to the 3rd times a to the 4 times 3. Remember, power to a power, you multiply the exponents, so 4 times 3 up on top there. And on bottom, we've got 5 to the 3rd, b to the 3rd. Alright, let's simplify what we can. So we have 3 to the 3rd is 3 times 3 times 3, which is 27. And a to the 4 times 3 is a to the 12th. In the denominator, we've got 5 to the 3rd, which is 5 times 5, 5 times 5, which is 125. And b to the 3rd, you can't do anything with. Now, the reason this is the final answer, and you can't do anything else with this, 2 reasons. 1, 27 over 125 is a simplified fraction. You can't simplify that any further. Okay? Also, you can't use the quotient of powers rule for this a to the 12th and b to the 3rd. You can't subtract those because they're not the same base. They're different. All right, so because of that, this is as simplified as it gets. Now, number 8 here is the most difficult one that we've got. So let's do this one. First, we need to do the power of quotients. Okay, so distribute the 7th to both the x to the 3rd and the y. And we'll have x to the 3rd to the 7th over y to the 7th times 1 over 3x to the 8th. Alright, let's simplify up on top here. Remember, to the power, you get to multiply the 7 and the 3. So we've got x to the 3 times 7, which is 21, over y to the 7th times 1 over 3x to the 8th. Now we're multiplying these two fractions together. And in order to multiply fractions together, you just multiply right across the top. So x to the 21st times 1 is just x to the 21st. And y to the 7th times 3x to the 3rd. You can't really simplify it all, but you can combine them together. So we've got 3x to the 3rd, y to the 7th. Okay? Now with this last step here is we could simplify whatever we could simplify. So if there was a number up here, a coefficient up here that we could simplify with 3, you would do that. If there was a y up here, you could subtract with y to the 7th, you would do that. The one, since we don't have those, all we have is the x on top and the x on bottom. That's all we're going to simplify. So the way that you rewrite that, remember x to the 21st over x to the 3rd is going to be done by doing the quotient of powers. So x to the 21st divided by x to the 3rd is the same as x to the 21 minus 3. Okay, and on bottom we still have our 3y to the 7th. Alright, and to finish this up, 21 minus 3 is 18. So x to the 18th over 3y to the 7th. Like I said, that is the most difficult one on here. That's a tougher problem. So make sure you're ready for the homework quiz, guys, and I'll see you in class.